Welcome to ASA 103, Basic Coastal Cruising. I'm Mike Rice, owner of Puget Sound Sailing Institute. And I want you to know we are dedicated to you learning the material and that you are really qualified to the level that we are certifying you to. So come along and let's get started. Now, ASA 103, you are going to be following along in the textbook. And the textbook covers all the subjects. This video is going to not cover everything in the text, but it's going to expand and give you added information on subjects that I feel are very, very important. So you could either read the textbook completely and then come back and watch the video, or as you read the text and we cover some of these subjects, then you could watch the video on that particular subject and then go back to the textbook. Well, let's get started. Now, the other thing I wanted to talk to you about was the International Inland Rules. And when we talk about sound signals and lights and shapes, we're going to be discussing this book here. And if the boat is 12 meters, 39.4 feet or larger, they're required to have a copy of this on board. But these are important things also that we're going to be talking about. Later on, we're also going to be going over to the chart table and teaching you how to do basic navigation. Well, let's get started. So, basic coastal cruising, our first topic that we're going to talk about is maneuvering under power. And most single engine boats have a right-handed turning propeller. So the propeller, as seen from astern, is turning to the right. So you can see from the slide in forward gear, it is spinning the boat forward, and from the propeller shaft, the propeller is in front of the rudder. And that's important to understand at this point. In reverse, the wash of the propeller is going towards the keel. Now, I want you to first do the reading, page 1 to 25. That's just talking about nomenclature and systems. So this maneuvering under power is covered in the textbook in pages 26 to 43, 114 to 121, and 156 to 159. This slide that you see here is from page 35. So a right-handed propeller. Now, this helps us to understand a very important concept of prop wash. Here we are in the second slide. The deficiencies of single engine boats is that unless they have forward momentum, they can't turn. Twin engines, you can use the torque of the twin engines to turn the boat. But here we don't with a single engine unless we have momentum. Here's a way we can cheat the system. Again, we understand that the rudder is aft of the propeller, and if we turn the wheel or turn the tiller so that the rudder is angled, then as we give a quick thrust of power to the engine, it'll hit the rudder, and like a jet, it will turn the boat. And so the trick is we can use this to help us to turn the boat without moving. And that is so significant. There'll be a time in your boating career where you are hard over and you're not going to make it. And here's a little trick to help you to overcome this natural deficiency of a single engine boat. Again, Remember, it works because the propeller is in front of the rudder, and of course the rudder must be angled one way or the other. The next one is prop walk. Again, we have a right-handed turning propeller, and when we put the engine in reverse, this natural rotation pulls the stern to port in reverse. Now, boats have varying amounts of prop walk, and you always, when you're on an unfamiliar boat, get it out in open water, put it in reverse, give it a little bit of throttle with the rudder straight, and see which way the boat spins. Most single engine boats will walk the stern to port, and that is in reverse. So this is one of the tricks you're going to do in maneuvering under power, is you have to use this knowledge that what your boat is going to do in reverse to help you. Okay, now what can you do if your boat has a strong prop walk and you need to get the stern to go to starboard? The key is to get the motor in reverse, get some speed, and then shift into neutral. Remember, it's the turning of the propeller that is causing that torque. And so once you put it in neutral, the prop isn't spinning, and so then your rudder can take over and work. And once we understand those two concepts, on page 36 of the textbook, they talk about the standing turn, also known as the three-point turn. This is another way where a single engine boat can turn the boat in a tight radius. And so what you do here is you use your prop wash and prop walk to turn the boat in a tight circle. Now, you need to understand that with a right-handed propeller, this is only going to work turning the bow to starboard, not turning to port. So as you can see, you alternate with the rudder hard over, slow forward gear, and then slow reverse. When the boat stops, back to slow forward. You start getting too much momentum, then back to slow reverse. You're only using a little bit of throttle. The key is to try to turn the boat in a very tight circle. Now, one thing you have to watch out for while you're turning around in this tight circle is watch out for any current or wind, which could be moving you also. And so you need to take that into account. So wheel hard over, little bit of forward, start getting a little bit of momentum, then a little bit of reverse, you stop, back to forward, etc., and use what you need depending on how much constraints of distance you have, back, forward, and reverse. And this is called a standing turn or a three-point turn. And again, you're using your knowledge of prop wash and prop walk to make this happen. Now that's our first topic, maneuvering under power, and you're going to be, of course, practicing these things out on the water. Now we want to turn back to sailing. And first we want to review sail trim. And in your textbook, you want to look at pages 74 and 75. Now when you boil this down to its simplest form, you have two modes of powering the boat under sail. You have lift and you have drag. And lift is when the wind is hitting the luff of the sail at a very small angle. Let's call it 5 degrees. Big enough to fill the sail with wind, but small enough that you get airflow on both sides of the sail. All right? And we use lift when we're sailing close hauled, close reach, and a beam reach. Now, unless you're an America's Cup boat that only uses lift because of their extreme speed, most modern day sailboats still use the ancient form of propulsion called what we now call aerodynamic drag. And drag is just surface area exposed to the wind. So we want the wind to hit the sail at 90 degrees. It pushes the boat along. You can see there's nothing but dead air on the leeward side of the sail. Very inefficient, but it still can help us to sail on a broad reach and a run. Okay, so lift, 5-degree angle between the wind and the luff, airflow on both sides of the sail, close hauled, close reach, beam reach. Drag, we want the sail 90 degrees to the wind direction. It's just surface area exposed to the wind, 90-degree angle, dead air on the leeward side of the sail. We still use this on a broad reach and a run. Here we have the old-fashioned seagull eye view of points of sail. And of course, head to wind, we're just reviewing our points of sail. We can't sail the boat head to wind because the sails will luff. The first real point of sail is sailing close hauled. And here what we're doing is sheeting the sails in, hauling them in tight to the boat with the sheets, and then pointing the bow as close to head to wind as we can without luffing. And we've got telltales to help us to look at the airflow over the sail. Then a close reach, we're also using lift, but here we're holding a steady course and we're making the adjustment with the sheet trim. So if the windward or inside telltale is bad, we're luffing, so we're going to sheet in a little. If the outside or leeward telltale is bad, we're going to sheet out. Okay, in, out, out. And we always start with the farthest most sail and work our way aft. So trim the jib first and then the mainsail. Beam reach, we're also using lift. Here we basically want the sails out as far as we can get them without a luff. And then broad reach, we are now using drag. So get the boom on the mainsail 90 degrees to the wind and then trim the jib so that the middle of the jib, or make an imaginary boom along the foot of the sail, get that 90 degrees to the wind. You're going to notice the apparent wind decreasing, and you're also going to notice the boat slowing down because we're using the wind less efficiently. And then of course there's running, where we want the sails out 90 degrees to the wind. The wind is dead behind us. Now once we master the concepts of sail trim, and trim is adjusting the angle of the wind to the sail with the sheets. And we want either 5 degrees or 90 degrees. And that's what you learned in 101. But now we're going to delve into a whole new subject called sail shape. We're trying to shape the sails for different wind strengths. This is our third topic, sail shape, and you can read about this in the textbook on pages 70 to 73. Now in this slide, you can see we're just looking at a mainsail for demonstration, and the little circle in the front, of course, is the mast. Now, the sail shape, first of all, if you ever have to choose between trim and shape, you choose trim. But we have so many controls on our sails now that in most cases, we don't have to choose between one and the other. All right, now there's 3 things we're interested when we talk about sail shape. And the first is what's called draft. Draft is curve or camber in the sail as the wind fills the sail with wind. And the first thing about this draft or camber we're interested in is what's called the position of the draft. So we're drawing an imaginary straight line from the luff to the leech, and that's the dotted line in your slide. And the sail will fall to leeward, hit a maximum point, and then come back. Now we express that point of maximum distance to leeward starting from the luff and express it as a percentage of the length of that imaginary line. Okay, so this is what we call the position of the draft. Now, in the head sail, we want it somewhere around 35 to 40%, so a little bit forward of the middle. 60% would be aft of the middle. So, in other words, 40% means the distance from the luff to the position of the draft is 40% of the width of the sail at that point. On the mainsails, we have to move it a little further back at 50% because the jib is throwing air back into the mainsail. The mainsail is always essentially sailing in a header. A header is a wind shift towards the bow. So we have to have the draft a little further aft. It's not ideal, but it's what we need to do. All right, now in a minute we'll learn how we can change the position of the draft, but let's just introduce the concepts right now. The second thing is the depth of the draft. And position of the draft, we always want at that percentage in the sail. Depth of draft, we vary with the wind velocity. If you know your aerodynamic lift theory, you know, with the airflow over the wing, the more curved the wing is, the longer distance the air has to travel, so it accelerates because it's got a longer distance to travel. And when you curve the sail more and you accelerate the air on the top of the wing or on the leeward side of the sail, that causes, it powers up the sail. So when you have a full draft, a very curvy sail, that powers up the sail. And of course, we would want to do that in light winds. In stronger winds, we've got too much power and we want to depower the sail, and we do that by flattening the draft. Again, we'll talk about how we do that in a little bit. So we have full draft, flat draft, and again, heavy winds, we want a flat draft. So the ratio of how far the sail falls to leeward compared to the length of that imaginary line, in other words, the width of the sail, is like 1 to 20. Now, you're not going to say, oh, okay, we got 6 inches and here 10 feet. That's 1 to 20. No, but just to give you an idea of when we're talking flat, we're talking very flat. Medium winds, we want something in between, maybe a 1 to 8, where the sail is falling to leeward 1 amount versus 8 for the width of the sail. And light winds, we want a very full draft, so like a 1 to 5 of this D to L ratio, distance the sail falls to leeward compared to the length of that imaginary straight line. Again, you're not going to be out there measuring it, but just to give you an idea of what we're talking about by full and by flat. The third thing is twist, and when the wind pushes on the sail, because it's a triangular shape, the sail will try to twist so that it would luff at the top. And as you can see in the slide here, we're cutting the sail at heights 1, 2, and 3. And the top diagram shows a sail that has no twist, and you can see that the sail has even shape from top to bottom. The bottom diagram and the diagram on the right shows a twisted sail, where, as you can see, a huge difference between the sail at height 1, where it's basically going fore and aft, and 3, where it's going sideways, a beam of the boat. Huge difference in the sail. This one causes inefficiencies in our ability to trim the sail. And second of all, if you look at that diagram on the right, especially with the mainsail, it'll cause a huge full draft and will power up the sail exactly when we don't want to power up the sail. Okay, so that's what twist is. It's only caused by the wind, all right? The wind, in a light breeze, you're not going to have any twist. Now, what controls do we have to handle all this? Well, on the mainsail, we have a couple of controls. And let's first talk about twist here. And with twist, it's tension on the leech, which is taking twist out or putting it in. If you allow the leech to go loose, the sail is allowed to twist. If we tighten the leech, then the sail can't twist. How do we control that? On the mainsail, you know, we can do it if we're close hauled or on a close reach with the main sheet and the traveler. So in light winds, we might want to move the traveler to windward so we can ease the sheet a little bit. Understand, if this is the boom and this is the main sheet and here's the bottom block, when the boom is way to leeward, the sheet is not pulling the boom down. It's only bringing the boom closer into the center of the boat. But once the boom is over the bottom block of the main sheet on the traveler, tightening the main sheet is pulling the boom down, which is tightening the leech. In light airs, we might over trim the main sheet, but we're trying to sail close hauled, so we need the sheet tight. What do? Move the traveler to windward so we can ease the sheet a little bit so we don't have as much force on the leech. Now in medium winds, maybe the traveler's amidships, and in heavy winds, we're going to move the traveler to leeward so we can get more tension on the main sheet to flatten the draft. And this is a great heavy weather technique, to move the traveler to leeward in stronger winds. Now, what other controls do we have on the mainsail? Okay, we've talked about the traveler and the main sheet, but we also have the outhaul, and the Cunningham is an eye and a line that runs through the luff of the sail near the tack, and that is going to be tightening the luff. The outhaul is pulling the sail out along the foot, and so that is tightening the foot of the sail. And the main sheet and traveler, when the boom is in range of the traveler, can control twist. And if any point of sail, we also have the boom vang, which can pull the boom down and tighten the leech. I want you to understand that we have three things of sail shape. We have depth of draft, position of the draft, and twist. Each one is primarily controlled by tension on one side of the sail. So the luff tension primarily moves the position of the draft fore and aft. The outhaul, or the foot tension, primarily controls depth of the draft, flattening or making the sail fuller. And remember, leech tension controls twist. Leech tension controls twist. Now these are the controls we have on the mainsail. What do we have on the jib? On the jib or Genoa, we really only have two controls. These controls are the halyard, which tightens and loosens the luff, and then we have the jib block. We would never use the sheet for sail shape. So, you know, if we say, oh, I need a deeper draft in the mainsail, I'm not going to let the jib sheet out and have the sail luffing to get a deeper draft in the head sail. Okay, so we really only have the halyard, which controls luff tension, which is changing position of the draft, and then we have the jib block. As we move the block forward, the pull is more on the leech. It tightens the leech but loosens the foot. As we move the block aft, it tightens the foot, pulls more horizontally, but that loosens up the leech and increases twist. Now, the way we check proper jib block position is you sail close hauled with the sails in tight in at least 10 knots of wind, and you slowly come up towards head to wind. And what you want is for the telltales on the jib to break, first slightly at the top and then the middle and then the bottom in pretty rapid succession. Now, theory-wise, they should all break at the same time, which means you have no twist. But in practice, we have a thing called wind shear. The wind bends as it is higher off the water. And so we want the top telltale to go bad slightly before the middle and the bottom. If that happens, that's the correct jib block position for that sail. Now, if the bottom telltale goes bad first, the foot is too loose now, and so we need to move the block back, move it aft, if the bottom telltale goes bad. That's pretty hard to do. You've got to really have it in a wrong position for that bottom telltale to go bad first. But if it does, that's what it's telling you. What happens more often is the top telltale starts going bad, indicating luffing at the top first. Remember, twist means the sail will luff at the top. So if it's luffing at the top, we have twist in the sail. We need to tighten the leech. How do we do that? We move the block forward, and that will pull down more on the jib sheet. All right, let's now summarize all of this. And again, position of the draft for all sails is controlled by luff tension, depth of draft by foot tension, and twist by leech tension. On the mainsail, the position of the draft, we can move it forward or aft with a Cunningham or downhaul. Now, some boats have neither, so then you would use the halyard. If I tighten the luff of the sail, it'll move the position of the draft forward. If I loosen the luff tension, then it's going to move aft. Now, also understand with Dacron sails, as the wind increases, the sail will stretch and the position of the draft will move aft. So if you set the position of the draft when you're sailing in 10 knots, when the wind increases to 20 knots, you're probably going to have to tighten the Cunningham a little bit more to pull it back to that 40 or 50% that you want. And on the jib, you're going to have to tighten the halyard a little bit more. Well, that's on the head sail. On the main, we're pretty much using the Cunningham or downhaul. Now, the depth of draft, we vary with the wind velocity, and that's controlled by foot tension. On the mainsail, we have the outhaul. And if we tighten the outhaul, it tightens the foot, that flattens our draft, depowers the sail. And if we allow the mainsail to have a fuller draft, we do that by loosening foot tension, which means easing the outhaul. This is the number one thing you can do when you're not quite ready to reef, but the boat is being overpowered. And we'll talk about when you know a boat is overpowered when we get to heavy weather sailing and reefing. What you need to do is luff the main. Don't try to do it when it's under load. Tighten the outhaul. That'll flatten the draft. That'll change your angle of heel and your weather helm almost instantly, more than anything else you can do on the boat. Then twist is controlled by leech tension. And we can do this with the traveler and the main sheet when we're close hauled or close reach, when the boom is over the traveler. And again, if we tighten the leech, that decreases twist. If we loosen the leech, it increases twist. Or since the boom vane goes to the base of the mast, we can tighten it and it'll keep the same tension on any point of sail as we sheet in or sheet out the sail. But it's usually easier to sail close hauled or a close reach and set the twist with the main sheet, then tighten the vane, and it'll keep it that way no matter what point of sail you go on. The head sail has the same three things. Position of the draft controlled by luff tension, depth of the draft by foot tension, twist by leech tension. But as we said, we only have two controls. The position of the draft is primarily controlled by luff tension, and all we have is the halyard. So again, you would want to luff the sail if you want to adjust this, and then you would tighten the halyard. That will move the position of the draft forward, or loosen the halyard would loosen the luff, and that will move the position of the draft aft. Typically, just from an observation standpoint, on the mainsail or the jib, if you have wrinkles horizontal along the luff, you usually don't have enough tension. And if you have a vertical bulge along the luff, you have too much luff tension. That's just kind of a visual cue without even looking at your position of the draft. Now, depth of draft and twist are simultaneously controlled with the jib block. And again, if we move the block forward, we're tightening the leech, so that decreases twist, but we're loosening the foot, and so it's giving us a fuller draft. And as we move the block aft, it's pulling more horizontally, tightening the foot, which decreases our depth of draft, but it loosens the leech, which increases twist. And what we want is that in-between position where we have pretty even tension on the foot and on the leech. And now you know how to check that by going close hauled and slowly coming up towards head to wind and watching your upper, middle, and lower telltales. If you only have a bottom set of telltales, then just look at the sail for a luff. All right, this is our section on sail shape, position of the draft, depth of the draft, and twist, and how to control it in the mainsail and in the head sail. All right, the next thing we want to talk about, our fourth topic, is boat balance. And boat balance and heavy weather sailing really go hand in hand. And you can read about this on page 16 through 19 in the textbook, and also pages 60 and 61. And the sail shape, I don't think I mentioned that to you. Sail shape is also in the textbook on pages 70 through 73. Sail shape. Look, you can look there in your textbook. Okay, so now the next thing we're talking about then is we're talking about boat balance. And this is our fourth topic. Now, I usually, when I teach this class live, I tell a little story of my brother and I as kids on a teeter-totter. But first, let me introduce a couple of concepts, and then I'll get to the story. All right, in the first place, what we have is a force in the sails we call the center of effort. And the way to determine it, as you can see on this slide, is you take each of the corners. Remember, we have a triangular shaped sail, both the main and the jib. Go from each corner to the midpoint on the opposing side. So you go from the head to the midpoint of the foot, and from the tack to the midpoint of the leech, and from the clew to the midpoint of the luff. they will meet in one little point, and that's the center of effort of that sail. So you get the CE of the main, the CE of the jib, draw a line between them, take the ratio of the areas, and that is your total CE. Now, for teaching purposes, some people understand it better if you understand the main and the jib as a separate thing, as opposed to a combined center of effort. And so you can look at it either way. Now, second is, as you can see in the diagram, we show on that right top diagram, we show the underbody of the boat, and you take the geometric midpoint of the underbody of the boat in 2 dimensions, not 3, and that we call the CLR, the center of lateral resistance. It's also called the center of lateral plane. In layman's terms, that's the pivot point around which the boat will pivot. And on modern day boats, it's going to be on the keel. Okay, so we have the center of effort in the sails, and we have the center of lateral resistance. Now, you need to understand a force called moment. Moment is the amount of force exerted away from the pivot point. All right, so for instance, take my elbow. If I push on my elbow or push on my arm near my elbow, it takes a lot of force to move my arm. But if I push way up high on my hand, it's easy to move my arm. So moment is the amount of force exerted times the distance from the pivot. And this becomes very critical when we talk about where the center of effort is in relation to the center of lateral resistance. In the next slide, we talk, let's see what a balanced helm would look like. Now, what do I mean by a balanced helm? I mean you let go of the tiller or wheel and the boat sails straight. And in theory, the center of effort would be directly over the center of lateral resistance. So there's no moment at all to turn the boat. Now, in practice, in practice, the center of effort is really going to be slightly forward of the CLR. But let's just assume for teaching purposes, center of effort directly over the CLR, we're going to have a balanced helm. Now, when lee helm is when the center of effort is forward of the CLR. And so what's happening here, first of all, what is lee helm? Lee helm is you let go of the tiller or wheel and the boat tries to fall off. And if you have a tiller steered boat, you have to keep the tiller to leeward just to keep the boat going straight. What causes a lee helm? It's when the center of effort is forward of the CLR, pushing the bow to leeward, away from the pivot point. All right, now as we can see, a head sail is forward of the CLR, so a head sail is always trying to push the bow to leeward and either contribute to lee helm or counteract weather helm. Weather helm is, and I should say lee helm is never desirable. You never want a lee helm. You should either have a balanced helm or a very slight weather helm. Now, what is weather helm? Weather helm is when you let go of the tiller or wheel and the boat tries to turn into the wind. And if you had a tiller, you're going to have to keep it pulled to windward just to keep the boat going straight. A very slight weather helm or a balanced helm is what you're after. A strong helm is never desirable. Now, what causes a weather helm? It's when the center of effort is aft of the CLR, and that pushes the stern to leeward and kicks the bow into the wind. All right? Now remember, moment. So the distance between the CE and the CLR is going to determine how strong that weather helm is. The other thing is, remember, it's force times distance from the pivot. So in a light breeze, you're never going to have any helm because there's not enough force in the sails. But as the wind gets stronger, balance becomes critical because you have a stronger force, and it's going to, if you have a distance between the CE and the CLR, it's going to become readily apparent, and it's going to be very difficult to control the boat. So boat balance is very, very critical as the wind starts getting stronger, and we must understand it. So balanced helm, center of effort in line with the CLR. Lee helm, the center of effort is forward of the CLR. It's causing the boat to fall off. And weather helm, the center of effort is aft of the CLR, pushing the stern to leeward and the bow into the wind. Now there's one other aspect and about balance, and I'm spending a lot of time on this because it's kind of very light in the textbook, but this is a critical subject for you to understand. Besides the CE in relationship to the CLR, the other thing on a monohull is heeling contributes to weather helm. And so the way I could demonstrate this is the old snowplow ski turn. That when I was a kid, that's how I learned how to ski. You would go pigeon-toed, and you would weight and edge one ski and kind of take your weight off the other ski, and it would turn you in this direction. So what you have on a monohull are two water lines, and when the boat's upright, they're just pushing water aside. But as the boat heels, you dig in one of the water line, and the other water line is out of the water. And what it's going to do is, just like that snowplow skier, it's going to try to turn the boat in the direction of that heeled water line. And we modern day boats that are so beamy compared to ages in the past, this is way more of a critical issue, because the angle of the water lines are coming in even steeper, and it's really causing strong weather helm. Any of you that have been out sailing and you get a gust of wind and the boat heels and the boat spins into the wind, you've experienced boat balance caused by heeling. Now, back to that little story of my brother and I on the teeter-totter as kids. So think of the pivot of the teeter-totter as being the center of lateral resistance. And instead of the total CE in relationship to the CLR, another way to look at it is one force. Let's say this is the bow, so the jib is trying to push the boat that way, and the mainsail is over here trying to push the boat and pivot it that way, okay? So, you know, my brother and I, we hopped on the teeter-totter, and we're going back and forth, everything's fine. And then, what does he do? He jumps off the teeter-totter on the downstroke, and so I'm up in the air, he jumps off, it creates an imbalance, it creates a torque, forcing my little butt down into the ground. And then, of course, what does my brother do? Ha ha ha, oh, that was so funny. All right, so you can demonstrate, and one way to think of boat balance is the jib and the main pulling on each other, and you want them to pull evenly so that you have a balanced boat. Keep in mind, if you don't flatten the draft in the mainsail as the wind gets stronger, you're powering up the mainsail, unbalancing the boat, causing weather helm. That's why tightening the outhaul, flattening the draft is the first thing you should do when you start having balance issues. That brings us to our fifth topic, which is reefing and heavy weather sailing. Now keep in mind, as the wind increases linearly, maybe it goes from 10 knots to 15 knots, or, the power in your sails and what's happening with the waves from in the water, they're increasing exponentially, causing heel and balance problems. Now you can read about this on pages 60 to 67 in the text, and on page 76 to 79. This diagram is from page 76. Now when you're talking about reefing and boat balance, what you always want to do is to use your understanding of boat balance to tell you what sails you need to reef. That's critical to understand. Now, most modern day boats still use what's called jiffy or slab reefing, where you have a reef eye or kringle along the luff and the leech, and then you have what are called reef points in the middle. And this is jiffy or slab reefing. And you can see on this diagram, and again it's on page 76 in your textbook, the red line is your first reef and the green line is your second reef. And so basically what you're going to do is you've got to be sailing on a point of sail where you can luff the mainsail, so close hauled or close reach. You're going to keep sailing with the head sail. You're going to sheet out and luff the main. Be careful, you're creating a lee helm. And you release the vang, you lower the halyard, tighten the luff and the leech reef lines, and then the sail is reefed. And of course you're going to be practicing this out on the water. There's other ways to reef the main. Some boats have a special mast where the sail rolls inside the mast, and we call this roller furling. And some boats also have a special boom and the sail rolls inside the boom, and that's called roller reefing. But probably still 80 to 90% of boats use jiffy or slab reefing. No matter which system you have, as you reef the sail, and you can see on the left diagram we have a full sail, the middle one is our first reef point and the far right one is our second reef point. Now as we're reefing the sail, what are we doing? We have less sail, which means less power, less heel. The center of effort of the sail is going to go lower, so we have less heeling moment, and it's moving forward, less weather helm. So reefing the mainsail does everything we want to do. Most boats have 2 reef points. Boats that go offshore are either going to have what's called a storm trysail, a separate sail for heavy weather, or they'll have 3 reef points in their mainsail. But your average boat has 2 reef points. Okay, so less sail, center of effort going lower and forward, less heel, and less weather helm. Reefing the main does everything we want as far as achieving our helm and balance. On the head sail, we either have separate head sails or we have a roller furling head sail that we can reef to varying degrees. Now we got some terminology here. We take a tape measure and we measure from the head stay to the front of the mast. It's a physical measurement on the boat. This is called the J measurement. Then on the sail, we have a measurement from the clew perpendicular to the head stay or to the luff. This is called the luff perpendicular. Now, when we take the LP of the sail divided by J on the boat times 100, that gives us a percent head sail. Racing sails might be as big as a 150, 150%, where the LP is 1.5 times the J measurement. Cruising boats with roller furling head sails typically only have a 130, so they can reef it down to about 100%. On roller furling head sails, sailmakers pretty much agree that you shouldn't reef it more than about 30% of its area. Otherwise, it's damaging the sail. All right, so we either have separate head sails or we have a roller furling head sail that we can reef. Here's the critical thing. When do we know it's time to reef? You are heeling 20 to 25 degrees, or you have significant weather helm. Either one tells you your boat is overpowered and it's time to reduce sail. It's time to reef. If you don't reef, it's like you're out in somebody's sports car and the accelerator pedal gets stuck to the floor and there's a corner coming up. Yeah, so you're in trouble. All right, you're overpowered. Okay? And I want you to know, overpowering the boat does not make the boat fast. I used to do studies on my dad's boat when I was in high school. It was a 36-footer. We'd be railed down going 6 knots, and I moved the traveler to leeward and luffed the main, and all of a sudden we're going 7 knots. And it's because the mainsail was creating so much weather helm. We still had plenty of power with the head sail, but we reduced the drag of the rudder and we were going faster. So heeling is not fast. I know you think it is, because when you're first learning how to sail, you start going faster as you get more wind. But for the same amount of wind, if you can heel less, then you're better. Now, if you ever have anyone that you're teaching how to sail and heeling is just freaking them out, put them on the main sheet or put them on the helm and let them control how much the boat heels. It's the fear that I'm out of control which causes problems with people with monohulls. If they know they're in control, then they're not going to be so freaked out, okay? So if the boat starts heeling more than they like, they just dump the main sheet or turn the boat towards the wind. And all of a sudden, they're feeling more in control, and they're going to be more comfortable, and they're going to be okay with a little bit of heel. And also explain to them what I'm going to go over with you right here. Okay, now you say, well, 20 to 25 degrees, which one? Kind of depends on your own comfort level, and it also depends on how beamy your boat is. The beamier the boat, you can't tolerate as much heel, or it'll cause lots of balance issues. All right, now let's say we're starting out in 8 knots of wind with a full main and a 150 Genoa, or in a roller furling situation, it's going to be like a 130. Now, for most boats, unless you have a big head sail like this, a 150, the first thing you're going to do is to reef the mainsail. That's always going to be first. But if you have a big light air Genoa, a separate sail, you're going to need to go down to a smaller head sail. So let's say at 15 knots, this boat is heeling 20 degrees and has weather helm. And so with a roller furling head sail, you're going to reef the main first. If you have a big head sail, part of that head sail is contributing to weather helm, just like the main, and you want to go to a smaller head sail first. Then let's say in 18 knots of wind, we're overpowered again. So now we put that reef in the main, or if we've reefed the main first, now we're reefing the Genoa. And to reef a roller furling head sail, you got to sail close hauled or close reach. You're going to keep the main trimmed and sail with the main, luff the head sail, reef it, roll up your roller furling line, and then move the block forward and then sheet it back in. And you're going to be practicing that out on the water. Now in 22 knots of wind, and notice, as the wind increases linearly, the power is increasing exponentially, and there's a shorter gap of when we have to take the next reef point. All right, so now we're at 2 reefs in the jib. And then over that, 28 knots of wind, now we've got a second reef and a little teeny storm jib. But remember, the key is control your heel and keep the boat balanced. Now we know from the snowplow skier, if we don't control our heel, we can't balance the boat. We're going to create weather helm. But as you can see from this diagram, the sail are very centered over where the CLR would be. Now, let's say we're sailing with these 2 reefs and a storm jib, and we're overpowered again. Oh, and by the way, keep in mind, heeling is really only an issue when you're close hauled or on a close reach. Beam reach, broad reach, and a run, heeling really ceases to be a major concern. Now, balance might be, but heeling's not going to be a big concern. But let's say all of a sudden the wind pipes up to 35 and we're overpowered again with our second reef and our storm jib. What can we do? If we are going upwind, we're going to get rid of the jib and just sail with a reefed main only. And if we're going more reaching or downwind, we can get rid of the mainsail and just sail with that small jib. All right, and that will power us just fine. We can't go to windward like close hauled with just a small jib. Why? Because we'll create too much lee helm. All right, that's why we can't do it. Now, a lot of people, let's say you're just out for a little day sail and it's kind of windy. What you might want to consider doing, you're just going to be reaching across the bay, just unroll the head sail, and then you don't even have to mess with the main, and the boat should sail fairly well if you have a 130 head sail or even a 120 head sail. But as the wind gets stronger, those are your choices. Always keep in mind the Beaufort scale, and we introduced this in our 101 video. And what this does is correlate what the sea is doing to what the wind velocity is. And they have these forces from 0 to 12, and then you have the wind in miles per hour or in knots, or if you're a metric person, in kilometers per hour. But you start getting white caps at usually about 12 to 15 knots of true wind. So you start getting white caps, that's telling you, okay, I've got about that much true wind. And always learn to read the wind on the water, both direction, okay? Take the crests of the waves, 90 degrees to the crests is the direction of the true wind. And velocity, you're looking at the color of the water. Lighter is less wind, darker is stronger wind because the wind is ruffling the water, causing shadows. And you're looking at white caps. If you have a few white caps, you probably got about 12, 14 knots of true wind. If you've got numerous white caps, you might have 20, 25 knots of wind. So this will help you. Now also, before you ever go sailing on any day, you always want to check the NOAA Marine Weather Forecast. You can get this on your VHF radio. You can go on the internet and look up NOAA Marine Weather Forecast. Our area is Puget Sound and Hood Canal. And they will use some terminology that you need to understand what it is. And the first is what's called small craft advisories. Now in the old days, they would put up a flag, at a harbor or a marina. And one red flag meant small craft advisories, and at night they would have a red over a white light. But it means winds predicted to be up to 38 miles an hour, and/or conditions which are hazardous to small craft. What's a small craft? Well, probably 40 feet or less. Okay, and they're advising you, hey, it could be a little rough. Now, small craft advisories, we allow our club members to go out if they have this 103 class because they understand heavy weather sailing and reefing and boat balance. And we want people to have good experiences. In 101, you're not ready to go out on your own in small craft advisories, and we don't want you to have bad experiences. But if we have gale warnings, we ground all the boats, we tie them up to the dock and don't let them leave, even for a class. All right, in gale warnings, our winds predicted to be 39 to 54 miles an hour. Remember, the increase in the sea condition and in the power in your sails really increases exponentially. And you can see the day signals and the lights at night. Storm warnings are the next one. This is winds 55 to 73 miles an hour, and hurricane winds are 74 miles an hour plus. And then you have category 1, 2, etc. Fortunately, here in the Northwest, we don't get hurricane warnings. All right, but you want to listen to your NOAA weather forecast, and you always want to be checking it and updating it as you're out sailing. All right, now, what if you are past the point for just the double reefed or triple reefed main, or just the storm jib? What other extreme weather procedures are possible? Now, keep in mind, we're only talking extreme conditions. I have crossed the Pacific 7 times. I have sailed over 100,000 nautical miles across oceans. I've never been in a situation where I thought, this is dangerous, we need to, go below and get off the deck. Now, keep in mind that's one, because I'm on a good boat and I have a well-prepared crew. And the third thing is I don't go sailing across oceans in the wrong season. So that's critical. Never tempt Mother Nature. But if you're out there and you get stuck, there's a couple of things you could do. In 101 class, we taught you how to hove to, and where the jib is backed. Okay, but we're talking about extreme weather procedures. It should be a very small jib in front of the shrouds, less than 100%. And you turn the rudder to leeward, so it's trying to kick the boat into the wind. And it's the force of the jib versus the rudder that is keeping the boat. And you should, the boat should settle in on about a close reach. And you're going to make about a 45-degree drift, a little bit forward and a little bit leeward. Now, in real light airs, you can what's called lie a hull. Lie a hull is that top diagram, but only if there isn't any waves. If you have waves, lying a hull, the boat is going to roll and be it's a very dangerous situation. But if you're out in Puget Sound and you have flat water, and all you're doing here is exactly the same as hove to as far as the rudder, but you have no sails up at all. And it's the wind pushing on the hull, trying to push you to leeward. The rudder is trying to push you into the wind. And again, the boat should sit on about a close reach. Now, if you're crossing oceans, you also might want to learn these techniques that if it's even too rough to hove to. All right. And the first is a sea anchor. A sea anchor is a big kind of a canvas bag. And basically, when you have large waves, the big issue is if you have a 50-foot wave, it's going to, and it's going 30 knots, it's going to accelerate your boat up to 30 knots just like that. Nothing good can come from that scenario. So the whole idea of the sea anchor, or later on we'll talk about warps, is to stop the boat from getting pulled along on the ride that the wave is trying to take you down. If you deploy this canvas bag off the bow, it's called a sea anchor. If you deploy it off the stern, it's called a drogue. It's the exact same thing, just has different names. Now, most monohulls, you shouldn't deploy a sea anchor off the bow because the bow will fall off away from the wind, and then the wave can hit you more sideways. So most monohulls, you really want to drogue off the stern, all right? and the rudder is lashed down and you're off the deck. Of course, the weak point is a wave coming in and hitting your cockpit and filling your cockpit with water, or even stoving in your hatch. So you really have to have a storm hatch set up. The sea anchor off the bow probably works better with a catamaran, where you can have a bridle arrangement off the bow. If you do have a monohull, you really want like a bridle so that it's keeping the boat almost close hauled, maybe a 30-20 degree angle to the wind. You never want to kind of get pushed over onto the other tack. If you don't have a sea anchor and you find yourself in this situation, now remember, with these you have no sails up at all, and the rudder is locked down, tied with lines, not a wheel brake, amidships, and you just drag whatever you have, anchors, chain, lines, in a big loop from your stern, again to slow the boat down. And these are called warps. Obviously, these things are you're only doing it if you're caught in very rough weather offshore. If you're past the point of a storm jib or a double reef main being able to sail, you're dropping your sails and you're motoring into the nearest port. Okay, well, that is our section on extreme weather procedures.